Hello everyone. In this session, we'll discuss about shear force diagram and bending moment diagram for a cantilever beam with uniformly distributed load. Let us see a cantilever beam with uniformly distributed load. Now here you can see a cantilever beam. So we know that the cantilever beam is nothing but one end is fixed and other end is free. In this figure you can see the fixed end is A end is fixed end and B end is free end. On this cantilever beam, the uniformly distributed load is acting. So uniformly distributed load is nothing but the load is acting per unit length over the entire length of the span. Means from A to B, the load is same. Means the load is distributed equally. That is uniformly distributed load. So in this figure, you can see the cantilever beam of length L fixed at A and fixed at free at B, carrying a uniformly distributed load of W per unit length of a cantilever beam. So here for this cantilever the load is W per unit length. So here now calculate the shear force and bending moment values. To calculate the shear force and bending moment, first you have to take a section XX at a distance of X from the free end B. So if suppose this is the free end B, from this section to B point, this is the XX section. From this XX section to B point, the distance is X. So here, for this XX section, first you have to calculate the shear force and bending moment values. So now, here take a section XX at a distance of X from free end B. Let at that section calculate the shear force and bending moment. We know that the shear force can represent with F and bending moment is represented with M. So here we have to calculate the shear force at XX section. So shear force at XX section can be written as F suffix X. Similarly, bending moment at XX section, M suffix X. So now first calculate the Fx and shear force at XX section. So in this, have to consider right side of this XX section. We have considered the right portion of the section. The shear force at the section XX will be equal to resultant force acting on the right portion of the section. Here, how much of resultant force is acting on the right portion is nothing but here this is uniformly distributed load. Means the load is distributed over the entire span. W per unit length. So what is length from XX section to free end is nothing but X. And load is W per unit length. Means W into the length is X. So for UDL condition, have to consider the force acting on the right portion of the section is W into length of the right portion from the XX section. Means here W into length of the right portion of the section. Here the length of the right portion is for this XX section, that is X. So the total Fx is W into X. Force is acting at a distance of X. So here this is downward. So the right side downward will be positive. We know the sign convention of the shear force. The resultant force is acting downwards. So on the right portion acting downwards is considered as positive. So here the shear force at XX is positive. So Fx is equals plus W into X. This is the shear force equation, and in this X is nothing but this is the distance. So in this equation it shows that the shear force follows a straight line law, because here the x power 1 is nothing but here linear, that is nothing but straight line. If we'll get the square, then the diagram will be like a parabola. But in this shear force calculation, we'll get W into x power 1. So it is like a straight line law. So now this is shear force at XX section. Now if you want to calculate the shear force at B point and shear force at A point, then substitute the values of x in this equation. Here at B point, so we are taking from right to left. So at B point, means this is the starting point. At this starting point, the distance is 0. So at B point, substitute x equals to 0 in the above equation. Then we'll get the shear force at B. So shear force at B is nothing but F suffix B. In this equation, W into X equation, in X place substitute 0. Then we'll get shear force at B is 0. And similarly at A point. So in this cantilever beam, we have only two end points, that is B and A. So at B point is a starting point. We are taking from the right to left. So now at A point, from B to A, here the length of the beam is L. So here the shear force is F suffix A. Then we'll get the shear force at A is W into L. Here the shear force at B and at A. Now calculate the bending moment values, then draw the shear force diagram and bending moment diagram. Now bending moment calculation. So on this bending moment, first you have to calculate the bending moment equation for XX section. Bending moment for XX section. The bending moment at the section XX is given by M suffix x is equals. Here we know that the cantilever beam, if suppose this is a cantilever beam, on this cantilever beam the load is acting in this direction. So the deflection curve or the elastic curve for this is here, this is a fixed, so it is continuous up to some portion, then it will deform like this. So here the bending moment, the elastic curve is like this. So the sign convention for this is negative. So mx equals minus total load on the right portion into distance of the center of gravity of the right portion. So here the total load on the right portion is, we know that is W into X. And here the distance of the center of gravity from this XX section is, that is x by 2. So here we'll get the mx equation as minus wx square by 2. This is mx equation for the cantilever beam with UDL. So we know that here the equation, so suppose this is assumed as equation number 1. Now calculate the bending moment values at B and A. Before that, here in this equation, here this is x power 2. Means here this equation is follows a parabolic law. Here the bending moment equation, means the above equation follows a parabolic law because the distance power 2. Here the square indicates that parabolic law. Here the above equation follows parabolic law. Means in bending moment diagram, we have to draw a parabola. And here now calculate the bending moment at B and bending moment at A. So at B, substitute x equals to 0. Then bending moment at B, M suffix B. So in this total equation, in place of x, substitute 0. Then we'll get the total bending moment at B is 0. And similarly at A point, substitute x equals to L. Then bending moment at A is minus W into L square by 2. This is the bending moment values at A and B. Now Let us draw the shear force and bending moment diagrams for this case. First, draw the given cantilever beam with audl. So this is the given cantilever beam. End A is fixed and end B is free end. Consider the x section from the free end at a distance of x and draw the end line like this. And to draw the shear force diagram, first draw a baseline. Here we'll get the shear force values as positive. So you can draw the shear force diagram above this baseline. So at B point the shear force value is 0 and at A point the shear force is W into L. So, and this is a straight line law. And at X point the shear force is W into X. So now draw a shear force diagram like this. Here at X section we'll get the shear force is W into X and at A point this is W into L. And here this total shear force is positive. At B point the shear force is 0. At A point the shear force is W into L. At X section W into X. This total shear force is positive shear force. So draw the above the baseline. And now coming to the SFD, shear force diagram. And now draw the bending moment diagram. Here we'll get the bending moment diagram is negative. So first draw the baseline and draw the bending moment diagram below this baseline. At B point this is 0 and at A point we'll get the bending moment is WL square by 2. So here this bending moment diagram is like a parabola. So here from A to B draw a parabola like this, and this total portion is negative bending moment, and at the x section here we'll get the bending moment value as wx square by 2. This is wx square by 2, and at a portion we'll get the bending moment as wl square by 2. Here this one is negative, and this total bending moment is below the baseline. This is the shear force diagram and bending moment diagram for a cantilever beam with UDL condition. Thank you.